In this video, I'm going to be graphing different kinds of sequences that you are going to see. So the first is just the actual sequence listed out. So if you see something like this, you are actually given points. Your domain is always for sequences 1, 2, 3. They are consecutive integers and they start at 1. So your first point, if you were to put it in a little t-chart here, your first point is 1, 1/2. Your second term is 1. Your third term is 3/2. Your fourth term is 2. And your fifth term is 5/2. So I'm going to go ahead and draw my graph here. I'm going to have my x-axis, or what might be called my n-axis, and this would be considered my a sub n. I will have that go by ones, and I'll go ahead and have these go by halves. 2/2, which is 1, 3/2, 4/2, and 5/2. Alright, so that means my first point is here at 1, 1/2, and then at 2, 1, and then at 3, 3/2, 4 and 4/2, and 5 and 5/2. Alright, so there is my graph. I'm just graphing those points. That's how I would graph if I were just given a list and it says graph this sequence. Another example is if I'm given a rule. So here's an equation. It would be like I'm giving you y equals mx plus b. I give you an equation, so that means you should go ahead and find some points. Since it is given to you in slope-intercept form, you technically could graph your y-intercept, which is 3. You could graph your y-intercept and then use your slope, which is -2/1. So it would be down 2, right 1, down 2, right 1. So you know those are some points that you should get. However, our domain does not include that y-intercept. So here's what you would do. You have some n values, so that's your x and that's your y. Plug in 1, 2, 3, 4. I may ask you for 4 or 5 values. Doesn't matter. So if I input 1, that means -2 times 1 plus 3. And that gives me -2 plus 3, which is 1. -2 times 2 plus 3, it's -4 plus 3, which is -1. If I input 3, that ends up being -6 plus 3, which is -3. If I input 4 here, that's -8 plus 3, which is -5. And you can see it decreased by 2 every time, so that means your common difference, or your slope, is -2. So I would graph 1, 1, and 2, -1, and 3, -3, and 4, -5. Right, so this is linear. This is what would be called an arithmetic sequence, which means it should look like a line. Alright, and a third example. So if I say graph this geometric sequence, I should know that it's not arithmetic, so it shouldn't look like a line. So it should probably have a curve. Here I actually need to find my rule. And the formula for that was a sub n equals a sub 1 r to the n minus 1. So I need to plug in what I know. Luckily I am given r and I am given a sub 1. So a sub n equals 2 times 3 to the n minus 1. So this means I need to find a couple points. Alright, so I'm going to go ahead and plug in 1, 2, 3, 4, 5. Alright, so if I plug in 1, I get 2 times 3 to the 1 minus 1. I need to take care of my exponents first. So 1 minus 1 is 0, 3 to the 0th power is 1, so that's 2 times 1, which is 2. And then I get 2 times 3 to the 2 minus 1. That ends up being 3 to the first power, which is 3. So 2 times 3, 6. I'm not showing my work here. I can. Alright, so that's 2 times 3, which is 6. Alright, that's me showing my work. For the third one, you would put in 2 times 3 to the 3 minus 1, so that ends up 3 squared, or 9. So that's 2 times 9, which is 18. Keep in mind, this is geometric, so that means every single time I'm multiplying by 3, multiplying by 3, multiplying by 3. So here I should get 18 times 3, so that's going to give me 54, and then 54 times 3, since it's geometric, that means I have this common ratio, and that's going to give me 162, I believe. Alright, so I should be able to graph these. My domain, or my x values, my n values, they're always going to be 1, 2, 3, 4, 5. And looking at what I have to go by, I think I'm going to go by 25, 50, 75, 100, 125, 150, 175. So at 1, I'm going to be at 1, 2, 2, I'm going to be at 2, 6, 3, I'm at 318, 4, I'm at 54, so I hop up a bit, and 5, I'm all the way at 162. So I should see a nice curve there. And that is just how we graph different kinds of sequences. Keep in mind this was geometric, so that means I did have a common ratio, so I was multiplying or dividing. Here I was multiplying. On example 2, it was arithmetic, which means I had a common difference, so I kept adding 3 every single time. So that one looked like a line, and this one also looked like a line. Example 1 did, in which I'm just given the points. I don't actually have to find out the points. And that pretty much sums up how you graph different kinds of sequences.